Thank you so much. Thank you so much. We didn't know we had in common a long ago accident. 3 Mile Island started my career. But what I want to talk to you about is what we learned from that process about how to move forward and anticipate. You just heard the Admiral say it, right? If you wait till the signs are definitive, you're in trouble, it's already too late. Right? Same thing we hear from incident commanders in disaster response or urban firefighter, fire commanders. It's the same message, that to make our complex and interconnected world work like we want and to take advantage of all the positives that come, we now have to invest in building and reaching for resilience. And our message today is we can release the adaptive power of human systems. And those human systems include the technology. Let's summarize today. 3 drivers, right? We've heard about how fast things are changing. It's a steep gradient of change, lots of possibilities and opportunities coming from connectivity, sensors, automation, and, oh, wait a minute, it's 4, right? It's not 3, it's 4. That's what we've heard today, too. The 4th driver is people, right? Connectivity, we've heard about that. Everything is connected to everything else. We can get timely information, we can find out things, we can talk to different people. In fact, we can talk to the people we don't want to hear what we're saying, what we've developed or what we did, as in that last panel. Sensors, we're able to pick up information. We're able to track things. Just the little exercises we've been doing today, together here in sampling your approaches and background knowledge with different panels and themes we've discussed. Automation. Everyone, we got mentioned the Google car. The Google car that only drives in North Carolina on NASA's campus because snow in Chicago might not go so well, right? And I could tell you more stories about the Google car that may make you not want to drive on NASA's campus. So we think of autonomy, but the issue isn't that we delegate authority to the machine and say, take over and do this. It's the machines are necessary because of the scale that comes from the connectivity, the sharing, the sensors, the data flows that go around. Everything is working at scale, so we have these hugely automated systems. In the end, though, what are they all about? Us. They serve human purposes. That's why it's a human system, a human adaptive system. It serves our purposes. Why are they valuable? Because they extend our reach. We can see more. We can do more. We can connect more. We can synchronize more with others. So we are in the adaptive universe. We are in a network of extensive and hidden interdependencies. This is a found diagram from counterinsurgency operations drawn up by a consultant about the Afghanistan war, showing all the different themes and interconnections and agencies. A spaghetti diagram. This is a great image to remind you of what our interconnected world is like. I call it a tangled, layered network. It's not smooth and simple. We heard some speakers today focus on the positives when everything's in alignment and clear-cut connections. But it's really quite an extensive, with lots of hidden interdependencies that cascade in surprising ways. We see the law of unintended consequences, which isn't a law at all. It's a symptom of complexity. Right? We take linear analysis and say, let's project things this way. But in that complicated network, what happens? There's a set of reverberations that spread out, creating offsetting effects or counterproductive effects instead of what we thought would happen. In fact, we can't tell what will happen. We have to do what the Admiral said, right? We have to be prepared to adapt. We have to anticipate. We heard it in the closing at the opening talk this morning from Don. He used a great example of birds, right? Birds adapt. Birds adapt. We're people. No. Our message, my theme to you, the finding from the science that was pointed to earlier today at lunch from Victor, is people adapt how they adapt. Right? We would be able to handle new kinds of hawks. We would be able to handle new kinds of habitats. Right? Whereas they're locked into one pattern of adaptation, we can recognize the signs that the world is changing. You live in an adaptive universe. You power it. You create the pressures for others. You experience pressures they create. You grab technologies that tempt you that you can do more, do it faster, and do it in better ways. You are trapped by the rules of the adaptive universe. Problem is, it doesn't work the way you thought. Even Victor laying out those nice heuristics don't go all the way. It really doesn't work the way you think it does. And when you ignore its basic rules, and when you operate in these extensive interdependent networks, what will you experience? Right? A record of apparent success, improving performance scores, everything looks great, and then sudden, inexplicable collapse. And of course, what's the rationalization? As you mentioned, they usually call me up, Dave, why did these people do something strange? And I go, actually, right? Let me explain the first law of systems. System does what it was designed to do. It's just not what the designer intended. You designed a system where that behavior was built in because of the way they had to adapt to various problems, impasses, difficulties to make the system work, to fill the gaps in the tangled layered network. Let's give a little example. An Icelandic volcano. It spreads across Europe. A couple years ago, who would think that a volcano in Iceland would ground all of the aircraft in Northern Europe? Who would guess that Northern Europe couldn't respond effectively to assess the risk to commercial aircraft? Right? And you see over on that last panel on the right, see there's one little yellow plane left in France in the last picture from that sequence? I was on that plane. I was on the last plane out of Dodge. Luckily, we were consulting for Air France on safety, telling them exactly what was just said about how the CEO has to be fundamentally engaged and involved continuously in safety issues in a complex, interconnected world. Just like you heard, the same thing applies on computer security kinds of issues. And we'll go even further. All of a sudden, whoops, we're getting more and more on our agenda. I thought all this great technology was simplifying and streamlining my world. Oh, no, no, no. There's no free lunch. Oh, here's another one. Here's a cartoon from Jen Sorensen by permission. Right? In the 1950s, people imagined that all this computer technology would lead to shorter work weeks. Right? With powerful computers, there's more time for calypso music and highballs. Mad Men, right? Mad Men era. Right? Instead, what did it bring us? Round-the-clock productivity, round-the-clock work. Right? Even on the back here, I can tell somebody what's going on and update them on the state of our conference. On the other hand, they can interrupt me and say, hey, where's that proposal? It's due tomorrow. Why aren't you working on it? Right? So it's funny how these combinations have played out of effects. In general, in these tangled layered networks, there will be surprising reverberations of change. Now, what's the important point here? Is we think of those as the difficulties and the disasters that we just heard about. But you know what's one of the biggest drivers of the surprise? Success. Success. When you do things well, people take advantage of that, and that changes your organization, your people, the roles, what's exceptional, and what others do around you. Oh, let's take GPS. In England, there's a whole bunch of GPS-induced accidents where lorries, it's England after all, get stuck in little villages across England because GPS says there's a road. Unfortunately, the road isn't big enough because it's kind of ancient for the lorries, and so we now see signs like this: ignore sat nav and engage brain. Right? An example of the hidden consequences and reverberations. As our Yogi Berra, our famous American philosopher, right, would say, and I think he wasn't from North Carolina, but I bet he would have been a good honorary North Carolinian because of his wisdom. Even if the world were perfect, it wouldn't be. Surprise is normal. It's not rare. It's not something we don't have to think about or we only have a contingency plan for. It's normal in this world. In fact, we're going to have to fix Victor's picture a little bit because he may have left you with an impression that you can just pick one place on those curves when he drew those crossing S-curves. The answer is you've got to be able to handle both kinds of pressures. Economic pressure, right? Faster, better, cheaper pressure, right? Pressing down on you. That's what you're taking advantage of with those technological changes. You're asking people to do more, do it faster, and do it in more complex ways. We're not making anybody's life easier with the new technology, just like that cartoon, right? It gets utilized by effective leaders to do more. So where did this happen? Well, he said we needed to do a disaster. We're going to do one. NASA in 1999 had 3 space exploration accidents, and essentially the diagnosis was, in the independent accident report, remember it's always an independent report, increasingly brittle systems under faster, better, cheaper pressure. Inadvertently, the system got more brittle as managers were making good decisions that looked good locally because they were improving productivity and meeting schedule and responding to cost pressures. Well, what happened? It's a long story I don't have time to go into, a sad story, because essentially it got buried because it wasn't pleasant for the top of the organization to hear. So they didn't end up completely funding these original actions in the early OOs to build the science and engineering for how to create resilient systems. Instead, we had to wait till 2003 to have the Columbia accident. I got to advise the Columbia board on some of the factors that contributed to this, and guess what happened? We had the same essential diagnosis as in 2000. Brittle systems. It wasn't about components. It wasn't about a bad manager. It wasn't about a single bad decision. It was about a series of decisions that inadvertently ate all of the sources of resilience, right, under faster, better, cheaper pressure. So I have to be both economic. I have to respond to those short-term pressures as well as take a longer view, both for economic viability as well as system safety, and balance those 2 kinds of pressures. And resilience isn't about one or the other. Right? Resilience is about how you balance them. Right? If you don't balance them, if you only pursue faster, better, cheaper, brittleness goes up, you eat the sources of resilience, you start getting miscalibrated, you think your system works a lot better than it really does, and people have to step into the gaps to make the system work. They tame the dragons of surprise, and you don't even know there's any dragons to be tamed. You have offsetting effects in trade spaces because you think there's a free lunch from this technology. Right? This is an actual slide from 2000. Think about your organization right now today and whether this is true for you. You exist in a changing environment under performance demands and resource pressures. Drive down costs, shorter, more aggressive schedules, new partners and relationships, new roles, skill erosion, heightened stakeholder interest. Didn't we hear this all day? Right? This is the signature that you live in the adaptive universe, that you're entangled layered networks, and linear thinking will lead you into trouble. So what do we want to do? What we want to do is chart cycles of how people adapt at different levels. This is where we've made the best progress in building an understanding of how resilience happens. Right? And what we want to do is chart how a change reverberates through that tangled layered network. And what you do is you look for how one unit's response triggers another, which then becomes the trigger, and they change, and what they do then triggers another one. Ideally, we're looking for fluorescence. Think of the computer industry, right? When I moved to Ohio State 26 years ago, Sun Microsystems was the hot computer company in Silicon Valley. Most of you probably don't remember Sun. Their headquarters was in prime real estate in Silicon Valley, right? A company that didn't exist 10 years ago now occupies their headquarters, called Facebook. It changes. It doesn't simply change at the level of the startup, right? But rather it's that regeneration that Victor said. It's not that Silicon Valley has successful startups. It's that it has this ability to change, right? New cycles that each builds on another, creates a new capability. The latest cycle being the sharing economy. But a lot of people here remember the days before Google even, or maybe just the beginning of email, and the number of cycles we've moved through. That's what we'd like to see, where a change in one part of the network opens up beneficial changes in many other aspects of the network. But that's not what usually happens. What usually happens is the opposite. It stalls. Right? What happens is we introduce a change, and we think it's going to be beneficial, but instead it produces new bottlenecks and crunches. It increases the squeeze on people who are already working at the margins. Why did it take 40 years to get electronic medical records? Right? It's not because people were not tech savvy or whatever. It's because they continually failed to support clinical work. We can look at that history. Today, it is in use, and we have a conflict between clinical support and, all the medical people here know, billing, right? We have a conflict between different perspectives, different interests, different goals, right? And what do we want to make it go to be adaptive? We want to make it serve the patient. Right? And that kind of example shows where we can end up with breakdowns. Most of the time, we have our data from cases where things stall and people have to work around to make things go. We even have laws for how this all works. The law of stretched systems. Effective leaders will exploit every new advance to the limit, asking people in the various roles to do more, do it faster, and do it in more complex ways. Advances don't ease the burden on individual operators or workers, right? But they get asked to do more. We can boil it down to a simple saying. In the adaptive universe, yesterday's solutions produce today's surprises that become tomorrow's challenges. As was just heard on the panel, cybersecurity, not because it's cybersecurity, but because it's fundamental process in that connectivity and sharing world that technology has created, it is a chronic issue. It's a chronic issue like safety. It applies all the time. You have to pay attention. You have to invest in it all the time, even while you're focusing on your short-term, faster, better, cheaper. It also is a challenge that you're struggling, right, to build the balance, to build the resilient balance between being able to be prepared to handle surprise and also to meet the short-term pressures. Right? And that balance, that search is an ongoing one. Take a company that's very successful. They have a critical digital infrastructure. They build it. It works rock solid. People take advantage of it. What happens? Customers go up. The load on the system goes up. New kinds of customers take advantage of it. New kinds of products are offered. What happens? The people running that computer network have to continually change and update in order to keep it running. And what are they all? Paranoid they've missed something. All right, let me give you one crazy thing about complexity. And I'm going to give you a physical example of it. In the complex tangled layered network, there's something called strange loops. Strange loops. That's exactly what it is. It's a strange loop. It's something that provides a key function. So think of your digital infrastructure as providing key functions, right? Critical software services. A company for holidays, Etsy, or maybe your stock, when you do a trade on the stock market through your mutual fund, it goes through a computerized stock exchange. So the computer system becomes not simply a support for something, it also depends on itself. And the example of this in the real world is the heart. The heart's job is to supply oxygen to vital organs. One of the vital organs is the heart. The heart supports itself. That's a strange loop. Now that's fine as long as the heart's healthy. Right? And as long as your computer infrastructure is all working well, right, everything is fine, and you don't even notice these strange interdependencies. What happens, though, is when something starts to go wrong. Right? And in cardiac anesthesia, for example, you can end up at the paradoxical state for the sick heart, where you want to keep the heart's work low to reduce stress on the heart, and you simultaneously want to keep the work high in order to supply oxygen. How in the world do they pull that off? Interesting. But they do it every day in doing bypass surgery. Right? An interesting example of adaptive capabilities. But more important, it tells us something fundamental about the adaptive universe, which is this paradoxical state that when things are relatively normal, when the events that are happening are within the standard envelope of competence for this system, everything seems so smooth. Everything seems so easy. Everything seems so productive. Everything's going great. And then when a failure happens, how quickly it can build and cascade and challenge the limits and reach the brittle limits, and a sudden collapse happens. And then you're into a crisis. And you go, where did that come from? How could that have happened? Who did that? We go, no, that's actually a fundamental system characteristic. I can even show it to you in, oh my God, math. Well, it's nonlinear math, so I'm not sure how many people on the planet understand it. A few people pretend, but I'm not sure about them either, but maybe in another way. Right? So what we want to do is manage the complexity created by our advances in connectivity and sensors and automation, and we want to do it in a way that tilts over time towards fluorescence. That's what Victor talked about. He gave you great heuristics for how to tilt toward fluorescence. Here are just a few high-level examples of what we found to supplement what he gave you. One of the things is a tangible experience with surprise. The success stories where we look at this, mission control for space shuttle launches, an emergency room, right? And when they're working well in coping with challenge, it's because they have a tangible experience that surprise could occur, that something will challenge their limits of capability, and that they will need to adapt, and to adapt how they usually adapt to handle this particular circumstance, event, failure, or crush of patience. Second is an ongoing sense of unease. Zoran Perkov, written up in the Flash Boys high-frequency trading case, in fact, designed many of the software architectures that run your stock trades. How do they describe him? Paranoid. He's paranoid, despite a record of success, that tomorrow's stock market, right, there might be a problem with the software infrastructure. He has a continuing unease that things are more precarious than our past record of success. 3, human talent. The key finding here comes from many different settings. The military operational setting was hinted at in some comments on the panel, but also from stuff in social science from Elinor Ostrom, who won the Nobel Prize in 2009, first woman in economics, and she wasn't even an economist, she was an empirical scientist. And what she studied was how do we make these complex systems work? And the key thing was pushing initiative, decentralizing initiative to the point of action in the world. If you can decentralize initiative and then coordinate those islands of success and reinforce success, you can create an architecture for being effective, to tilt towards fluorescence. She calls that polycentric governance. That's one of the things, the scientific findings and theories behind some of the stuff Victor showed you. It's not just heuristics from somebody who seemed to do a pretty good job. There's solid science behind this, and that solid science can tell us more than just heuristics about how to do this. Another surprising one is you need to not just respond to faster, better, cheaper pressure, but always invest in building a potential for handling future surprise, to be able to gracefully extend the performance of the system when the next event isn't like the last event, when the next disaster doesn't match the one you planned or practiced. And the last one is reciprocity. All right, I'm going to trump a venture capitalist with a Nobel Prize winner, because Elinor uses reciprocity, but we actually agree. It's one of our problems in complexity. We use this word slightly differently because we come from different backgrounds. So reciprocity in Ostrom is a critical finding, and what that means is the paying forward that Victor talked about. Right? Not tit for tat, I'll only do something when you've done it for me. Right? Reciprocity means and notice this is very important, I can count that when I'm in trouble, when I am having a hard time executing, when I've got extra pressures, when I am in a crunch, or when a bottleneck's about to hit me, that you will adapt what you do to help alleviate my crunch. You will support me. And so when I see you in a crunch or running out of the margin to be able to handle things, I will help you. It's the anticipation that others will help as you approach difficulties and encounter surprises. So here's the crunch for you. What story are you going to tell? Are you going to tell a story that manages complexity and tilts towards fluorescence as connectivity, sensing, and automation capabilities continue to grow? Are you going to get trapped in linear simplifications? Oh, an automated car is just an automated vehicle. It's just a vehicle with some software inside. No, it's completely different, right? It's a whole bunch of computers. It's maybe 30 sensors. It's maybe 20 kinds of algorithms. It's a complex network. It's got life cycle issues, right? How are you going to manage and update those software? Remember the Toyota software bug? A Stack Overflow problem ended up killing a few people as a contributor to a pattern of accidents with unexpected acceleration. A software problem. How do you manage the life cycle of these things? So are you going to be on the negative side? Are you going to contribute to brittleness? Are you going to contribute to shortfalls where some responsible human in some low role has to jump up and take care and fill the gaps to make the system work, to create the function that you didn't understand? Are you going to be trapped in the trade-offs thinking there's a free lunch? Right? Or are you going to be part of a positive story? Are you going to start to investigate how your system already demonstrates resilience as graceful extensibility? And I mean that, graceful, that people are out there fluently making your system work. You may be some of those people making it work. Unappreciated, unnoticed. You're taming dragons every day, and some days you forget that you're so good at taming dragons. They show up all the time. And certainly, right, the upper layers of the organization may miss there are any dragons out there and think that their plans and procedures and automation cover the whole thing. So are you going to build initiative, right, create reciprocity like Victor laid out on the rainforest side? Are you going to build and adjust the capacity to adapt? In the end, let me leave you with a last thought. With apologies to Dickens, it is the most optimal of times. It is the most precarious of times. It is the age of sure wisdom. It is the age of overconfidence. It's the season of light shining from our omnipresent digital services. It is the season of darkness blinkered by production pressure. It's the spring of hope for autonomous machines. It is the winter of despair of complex networks. Before us is the allure of faster, better, cheaper. Before us is the experience of sudden, inexplicable collapse. Our system of systems is almost in clockwork heaven. Our systems are fragmented, running down the other way. Not one or the other, but both. These are the signs of the single world we live in, the adaptive universe. We can't finesse it. We can't hide behind simplifications. The question is, will you help systems learn how to adapt how they adapt? Thank you very much.
Thank you very much. That was good.